Hello there. In the previous video, we briefly talked about the structure of the PLC timer tag and some of the three basic instructions with the timer. So in this video, we're going to start to talk about how do we use the instruction and control bit in our program in the ladder logic. So before, mostly we'll focus on the done bit in this video. Then the next video we'll talk about the TT bit. So those are the two important control bits. So before we move on, a little bit of review from the timing diagrams with the two timers, right? So we'll just assume that we have this logic at the beginning. So we have a single trigger to start two timers, right? One is on delay, the other one is off delay. All right. So it could be a combination of triggers, but we'll just look at a basic single trigger, right? So the diagram you seeing on here is from the Rockwell manual, the programming manual. So this is a pretty good timing diagram, even though at the beginning you may think, okay, it's just a little bit overwhelming, but let me explain that. All right, so as we go through this timing diagram, you can have a basic review from what we understand with the PLC timer. All right, so again, so you can see the run condition in is just what we talk about the trigger, right? So when with the on delay, so this is yeah, I didn't make a note down here. TON, yeah, this is TON. Right. So this is on delay. So when the trigger is off, right, basically everything is clear to zero, right? So you can see here, enable is off, TT is off, done is off, and accumulation is at zero. So at this moment here, at this line, vertical line here, the trigger turned into true, and then you can see here the timer start timing. So when start timing, the enable is true, timer timing is true, but the done bit is still zero. Why? Because you can see here underneath here, the accumulate, which is a double integer, is start to increase, but the preset is at this level, right? So the trigger didn't last long enough to let the accumulation reach to preset, right? So this is just a very short pause of a trigger on here. Then it goes back to zero again. So from the timer point of view, this accumulation never reached to preset, so the done bit, nothing changed on here on the done bit. It's just like nothing happened. The only thing you can tell the difference is that the enable bit was true and timer timing was true for a brief period of time, right? So that's what it shows on here. Then after that, for a long period of time, the trigger keep being low, right? So that's what we call the reset. Right? The timer is just in the reset state, not timing, right? Not running. So then for the second time, when trigger start become true, so this time the trigger lasts long enough. You can see here, this is a very wide pause on here, so that will allow the accumulate reach to the preset. Once reach to the preset at this point, you can see the done bit, right? The done bit change from here, right? Change from false to true. And same as before, the enable will always follow the trigger, but the TT bit only lasts for the duration of the timing, right? That's why it's called TT bit, timer timing, right? It only lasts when the accumulate reach to the preset, right? And after that, done bit become true, timer timing become false, right? Then when the trigger become zero again at this moment, right? Because it's on delay, everything clear back to zero. So this is what this timing diagram tells you. All right, so let's move on to the next slide, which is the timer off, right? TOF. So with this, because the timer start when the trigger turn off, right? So if the trigger is true, like you can see here, when trigger is true on top, the enable always follow the trigger. The timer is not timing, it's 0. Done bit is true at the top. Again, that's from the previous run. Probably before it's already running on there. But the important part is that you can see the accumulation, nothing changed. All right. So this TOF is a little bit special. There's something not easily to understand at the beginning, but will take some time to understand. Right. So, but remember, the trigger turn off will start the timer. So enable, no argue about that. Always follow trigger. You can see timer timing start to time the increase, right? The increase on here. You can see keep going on here, but this time didn't reach to the preset. Right? Just like the previous one, we have two different scenarios, right? So this time the duration of the trigger didn't last long enough. It become true again on here, right? So that didn't make the done bit change to the opposite. Still, which maintain the same status, right? So then after that, this is going to reset state again. So after the second time, trigger become off, and then start a second round of timing. So when the timing maintain long enough to get the accumulation reach to the preset, the timer timing become true, then become false once you reach that. And then finally the done bit changes the state. You can see here, right? Once reached to the preset, it changes to the false, from true to the false, or from 1 change to 0, right? Right? Whenever the trigger become true again, that will reset the off delay. Because it is an off delay, right? The trigger become true will reset the timer. All right. So let's look at the next one. The next slide is just from different angle, to look at that again, depending on how do you look at that, right? So again, you can see here. So the trigger from here 0 change to 1. So from here to here, right? It's a on delay. T1 is on delay, and from here to here is a off delay, right? So with on delay, I'm not going to talk about enable again. All right. So let's look at the done bit. So this is just set up as 2 seconds. Right? Both actually at 2 seconds. So the trigger become true with on delay. It will start timing. Wait for latest one column represent 1 second. Right? So 1 second pass, 2 second pass. So the done bit will turn on. Right? So that's when you use the exam on, you will get logic true. So the top is logic true, and on the opposite, if you use exam off, right, you will get the opposite logic, right? For the 2 seconds timing, you will have a logic true. So once the timer finished the timing, it will change to false, right? So they are opposite. And in the same time, for the 2 seconds, you can see here, right, that T represents the preset, how long you set up for the timer. So that is what happened with the on delay for the first time on here. Then at this moment, it changed back to off, and that will reset the on delay timer. You can see here everything reset back to the normal. Right. Then for the second time, it will turn on the trigger for only 1 second. With this 1 second, the only thing change is the enable change to high, and the timer timing become true for only 1 second. It's less than 2 seconds, so that's why it's only here, right? And then because that goes back to 0, it reset the timer. And then next, for the third time, it lasts 3 seconds again. So with the first 2 seconds, you can see here, that's the TT bit. With the first 2 seconds, you will see some actions with the timer, but after 2 seconds, the done bit will make change out here, right? And I believe the same thing. I don't have to repeat on that. With the off delay, you can take a look with this, similar to that. All right. So I think the most direct way to demonstrate the operation of the timer is to look at the demonstration on the examples. Remember that we had some of the let me show you here. Okay, so remember at the beginning of the timer topic, I gave you 4 typical applications examples, right? So now I'm going to use the PLC simulation to show that the operations with that in action. All right, so that's all here. So the first one, if you remember that I have the comments on top. If you read on here, right? Let me see here. If you read this part, right? So that's the first example, right? With the flow switch to check the water level, right? So that has the 5 seconds delay. So when the flow switch is off on here, the pump is off, right? But when the flow switch turns on, you want to start 5-second delay, right? You don't want to turn on the pump right away, right? So wait for 5 seconds, then you turn it on, right? So this is the timing diagram to represent this operation. So this is a typical normally open, timed, close, right? So also it's a on delay. So I need to switch that just to okay. So with this normally open, time close, we have the on delay, right? So one thing is on delay. The other thing is that we want to use the done bit and exam on to get the function of that. All right. So let me switch here to the operation. So if I toggle this, toggle the bit, flow switch become true, it start timing, but pump is not on. Reach to 5 seconds, the pump start. Right. So when the water level low, then the pump become de-energized. Right. So notice, like I mentioned, if there's some ripple effect before reach 5 seconds, you can see here that could be that simulate. That's the ripple effect. Like only be on for brief period of time, didn't last for 5 seconds. So in this way, you protect your pump. Your pump will not being affected by this ripple effect. Right? Otherwise, you will see the pump turn on and off very, very quickly, very often. Right? So that's not what you want. Right? So the one thing probably you notice the tag on this program is a little bit different. You notice here it's T square bracket 1. Actually, you can see here, right? I use the array so to have all the timers in there, right? So you can just treat this as individual because the array is different topic I don't want to talk about here. So you can just treat this as a T1, T2, right? This is another one on there, right? So this is the first application example, right? Then let's look at the second one. So the second one is a door switch. If you look at here, right on here, right? We call that a dorm light, right? So right now, the door is open, right? It's off, right? And then the light is on. So you want when the door is open, the light turn on, right? So when you have the door closed, again, when you time the door close, it start 5-second delay. After 5 seconds, the light will turn off. Right. So this is just simulation on that, right? So if you look at the timing diagram, so this is the door switch and the dome light, and with the 3 second, or I use 5 seconds, similar thing, right? So this is typical normally closed, time open. All right. So for example, if you open the door, right? When door is open, this will become false. You will see the light turn on right away. There's no delay at all. All right. So when you close the door, and then when you open the door again before the 5 seconds, you can see the light still on, because it's still in the middle of the 5 second delay time. All right. So let me look at here. So all right. So let's look at the next demo. The next one is the cooling fan. Right. The cooling fan is controlled by a switch. So when switch is off, the fan is off. But when the switch turn from on to off, right? So when you turn on, you can see on the let me use here. So when you see the switch is off, the fan is off. When the switch turn on this moment, the fan turn on right away. Right? It will keep on until the switch turn off. When switch turn off, it start a delay. After a period of time, during this time, you want the cooling fan keep running for some extra time, then automatically turn off. Right. So you can see this is the off delay, and also it's the normally open, timed open. So how do you get normally open, time open? I explained that before, but you can see here this represents the normally open period, and instant close, and then timed open here. After this period of time become open. Then let's see if the PLC instruction will do the same as what we predict. So switch is off, fan is off. Then by toggle this, the fan turn on right away. Right? There's no delay when the switch turn on. Right? So because it's a TOF, off delay. So when switch is on all the time, the fan is on all the time. Right? When the switch turn off, the timer start delay, the 5 second delay, you can see the fan still running for actual 5 seconds, then turn off. That's exactly what we want for the cooling fan. Right? Then let's look at the last application examples. It's about the sprinkler for the lawn, right? So right now you can see that's a photo sensor to check if there are any pedestrian, right? So on the timing diagram you can see here, photo sensor is off, right? That means no people around, no pedestrian. The solenoid to control the sprinkler is on. You can see the water is spreading on there on the grass, right? So at this moment, photo sensor detect people close by. Then you want to shut off the solenoid right away. There's no delay, right? You don't want to hold on, right? You want to take action right away. So as long as people around there, the solenoid will be de-energized all the time. So at this moment, the photo sensor detect, okay, there's no people around now, right? And after that, we want to make sure, we want to hold for 2 seconds before we turn back on the water. Right, so this is what we expect with this timing function. Then let's look at if PLC can do that, right? So with this, you can see with the photo sensor is off and solenoid is on, right? The water is the sprinkler is doing its job, right? Then when you have people to trigger the photo sensor, you can see the solenoid turn off right away. Right? So it will keep being off as long as the photo sensor is on. Right? Then when photo sensor turn off, that means no people around. Then that timer will start timing. You will see the accumulation go up, right? Once reach to 5 seconds, this solenoid will turn back on, but it will not turn back on right away, right? So photosensor 12, the solenoid is not on for 5 seconds. When 5 seconds reach, it energized, right? So again, so this is just 4 typical applications. You can see the actions with the timer instructions.